Hi everyone, and thanks for joining us for this Wolseley Live session with Alpha. We've got a week of no-cost webinars this week. We had a couple yesterday. This is the first one of 3 today, all as part of Wolseley Live. So make sure to check out our Crowdcast page, which you're on now, and our website, and you'll be able to see all the ones coming up, and you'll be able to watch everything else that you may have missed on demand. So let's introduce you to our session today. First up, we've got Neil Jarman from Alpha. Neil, welcome. How are you?
Good morning. Very well, thank you. Looking forward to this.
Yeah, thanks for joining us. Can you give us a little bit of information about yourself and your role at Alpha, please?
Yeah, I joined Alpha back in September. I'm the Renewable Sales Manager for Alpha Heating.
Yeah, perfect. And we've got Dan as well. Dan, can you tell us a little bit about yourself and your role today, please?
Hi, Joe. So I'm the Renewable Product Manager at Alpha. I've just been with the company about a year now. And prior to that, I worked for a sort of medium-sized install company, primarily doing sort of vessels, heat pumps and stuff as well. So that's where we are.
Yeah, perfect. So if you guys, we've got a presentation now that Dan's going to run through. If you have any questions or comments, there's that chat box now. Hi, Michael, which people have put things in. There's also that ask a question button, which looks like a question mark with a speech bubble. So if you have any questions, we'll pop them to Dan and Neil at the end of the presentation. So pop them in that where it says say something nice or Q&A. But Dan, over to you for your presentation.
Nice one, thank you. Thank you all for turning up today, taking time out of your day to watch my presentation. So the idea of today is to give you an insight into hybrid heat pumps and why we think at Alpha they're a practical transition into renewable technology. So I'll just cover a couple of the objectives of today's webinar. So firstly, we're going to look at what is a hybrid heating system. So we're going to look at different types of hybrid heating systems, essentially what it is and how they can be implemented. We're then going to look at why we believe hybrids are the key to net zero. So why we think using hybrid technology, we can actually achieve net zero. Then we're going to look at existing heat pump technology in the UK. So we're going to look at what we've got currently in the UK and how it's panning out. And then we'll look at our European neighbours and see how they're getting on with their heat pump technology and installations. We'll then have a little look at the design and application of hybrid technology. So a little bit about the design and how hybrids can really be a benefit. And then I'll give you a little demo of our new Alpha E-Tech hybrid. And then hopefully you guys will have loads of questions and we'll do a nice Q&A at the end and hopefully I'll answer all of the questions you guys have. So moving on, I've done various training sessions over the last year and it's primarily been on heat pumps, but I like to get this out of the way at the beginning because it seems to be a big debate within the industry. Like, are we going to hydrogen or are we doing heat pumps? So I've just got some facts on the screen. I'll just run through some little bits as well. So hydrogen, it is an amazing fuel source. So we've created a gas that can burn, and create zero carbon. So it's a fantastic product. It's just very difficult to implement it at current. So I think we're looking over the next probably 10 years, we could potentially see 100% hydrogen. Some of the main issues come across how we actually get it down the pipeline. So our existing gas infrastructure, a lot of our gas mains would have to be renewed to be able to handle 100% hydrogen. I think the estimated cost, and this figure's been thrown around a little bit, but the estimated cost of actually renewing the gas grid to maintain 100% hydrogen is about £182 billion, which is a huge amount of money. And it's a very difficult process. We've only got to look at sort of cities like London, where we're looking at renewing the gas main. We don't even know where some of the gas mains are in London, so it's a very difficult process to go down. So I think at current, our best bet, and we will probably see this year, is a 20% blend of hydrogen. And you'll see on the right hand side of the screen there, that actually gives us a massive saving of carbon. So if you look on the right hand side of the screen, over a 9-year period, we're looking at a 41 million tonne reduction in carbon dioxide. So it's absolutely huge. And it just shows you at the bottom what that's equivalent to. So it's equivalent of 20 million cars off the road. So moving on, what is a hybrid? So generally, a hybrid is a heat pump and a fossil fuel boiler. So we're all used to the concept of hybrid cars. And we've kind of used hybrid cars as a transition from petrol or diesel cars into full electric vehicles. But there is some things that are stopping people jumping into full EVs. And I've just listed a couple of them here. So it's range anxiety, where can I charge it, and cost of electricity. Sorry. So obviously with our petrol and diesel cars, we fill it up and we can do 400 or 500 miles on a tank. See, with an electric car, we are limited and we then have to stop and charge it. So it puts a lot of people off going for EVs. We've also got where can I charge it? So obviously if we planned a route in at our service station, we get there and it's full of Teslas and we've got nowhere to actually get in and charge our car, it can obviously cost us some time. And I think the third point is that I've actually heard now that some people are saying that it's probably cheaper to fill your tank with petrol than it is to actually charge an electric car at the moment. So just before we start everything, I want to run through heat pump COP or COP. I think before we start diving in and understanding hybrids, we need to understand how heat pump technology works. So a lot of engineers say to me, how can something be 400% efficient? Well, this is essentially how it gets over 100% efficiency. So you'll see in this diagram here, we're taking 1 kilowatt of electrical input in. So that's to drive a fan and a compressor inside our heat pump unit. And we're actually stealing 3 kilowatts of thermal energy from the outside air. So this heat already exists. Even when it's -10 outside, there's warm air particles in the air. And we're actually compressing and condensing that and pushing it into 4 kilowatts of usable heat. So a COP of 400% efficient is really good. The main issue that lies with heat pumps is that the cost of electricity is generally 3 times more expensive than gas in the first place. So you've got a 90% efficient gas boiler, but we need about a COP on a heat pump of 300% or more, a COP of 3, to actually be in competition with a gas boiler. So how does it do it? So it uses a refrigeration cycle. So this is not new technology. We've all got this in the back of our fridge freezers. And it's a really simple process. It's much more simple than a combustion gas boiler. Essentially, in all of our alpha heat pumps, we use R32. So R32 is the refrigeration gas. And that's a pretty well-known refrigerant across the industry. A lot of manufacturers are using it. It's quite environmentally friendly. So what it does, so R32, this is the fundamental bit, it has a boiling point of -51 degrees. So at outside normal temperature, on a day like today when it's a little bit chilly as well, that is absolutely boiling. So what we do is we run it through on the left-hand side of our screen, we run it through an evaporator, and through that evaporator, we're drawing air across it with a fan. So that's our fan unit. And then we're taking that harnessed energy at the top and we're putting it through a compressor. So we're squashing it and making it hotter. So what we do is it's very similar to when you're using a bike pump. If you're pumping away on a bike pump, the pump itself generates heat through compression. And we're using that. So you imagine when we're back at school, we've got our solids and gas particles, and when they bounce together, they generate even more heat. And then pushing that as a high pressure vapor through a condenser up against a plate heat exchanger or a heat exchanger, and then running it through the system. And that's where we're stealing the heat and pushing it into the property. And at the bottom of the cycle, we're decompressing the gas. So I like to think of this as like a deodorant can. When you spray a deodorant can, spray the gas out, gas decompresses and the can goes really cold. So that the refrigerant's at its coldest state again when it runs back through the evaporator. And this cycle will continue and continue, and that's what generates heat into our property. So the less hard this cycle has to work, the less energy we're using to run it. So the less we have to get that refrigeration cycle to work, the less we're actually running it. So how do we do that? We're looking at low temperature. So you'll see at the graph at the bottom here, you'll see the arrow pointing at central heating mode COP with water set at 35. So you'll see at 35 degrees, when we're running at a 35 degree flow temperature, our COP is really high. So we're looking at COPs of 5 there, which is a really efficient system. But as we raise that flow temperature that we require for the property, the COP starts slipping away. As we said earlier, we have to have a COP of 3 or above to necessarily beat a gas boiler. So this is where hybrid technology is really clever, because we can use our heat pump when we need a lower flow temperature, and then when we actually need a high temperature, we can use our gas boiler, so we can make it more efficient. So I'll explain a little bit about the types of hybrids that are kind of on the market at the moment. So there's different names for them, but for all purposes of today, I'll be probably talking about a gas boiler and a heat pump. Is that the most common that we'll see? So this is adding a heat pump to an existing boiler. So that's a retrofit hybrid. So it's a low cost option. it's essentially using an existing gas boiler. So it makes sense that we're using a fairly new boiler. There's not much point in putting a shiny new heat pump system on a 15, 20-year-old boiler. It doesn't make much sense. So if you've got an existing boiler at the minute, it's in fairly good condition. It's about incorporating a heat pump into that system to manage the load, part of the load it can manage. Difficulties with having this system is obviously you've got warranties spread across 2 different manufacturers, and potentially you might have someone to come out and service the heat pump, and a different guy come out and service the boiler. So there's variables to it. Then look at types of hybrids. So this is a combination hybrid. So this would probably be sold as a package. This is one of the products that I'll unveil to you at the end. So this is a new gas combination boiler fitted with a new air source heat pump. Bonuses of this is it's instantaneous hot water, and people love a combi boiler. In the UK, it's probably our best-selling heating appliance is a gas combination boiler. It takes up minimal space within the property. It's an ideal retrofit solution, and sometimes it will need a detailed design. So we'll have to work out how much of the demand of the heating system is the heat pump going to manage, and then what demand is the gas boiler going to manage. And we've got to make sure that they're piped correctly in between. So this is hybrid with stored hot water. So very similar. It'd be a heat-only boiler or a system boiler, and it would utilise the best technology at the right moment in time. Difficulties with this one is you might have a new boiler already, but if you've got a boiler, you would need to upgrade your cylinder. If you want your air source heat pump to heat your hot water within your cylinder, we need that larger coil. Because we're operating at a lower temperature, we need a larger cylinder coil to transfer that heat. So initially a high upfront cost, but very much future-proof. So whatever happens with the gas and electricity prices, we're covered. If gas suddenly skyrockets, we can utilise our heat pump more, and vice versa. So why us at Alpha? Why we believe hybrids are the future for UK heating? So we're really difficult, and especially in Europe, we've got probably some of the poorest housing stock in terms of installation and heat loss. So it's very difficult to get low temperature systems in properties that are going to be efficient in our older style properties. Also, we seem to have built houses really close together, so we've got lots of terraced houses and stuff that make it actually quite difficult to get a full-size heat pump in the rear garden. If you think like a 2-bed terraced house and stuff like that, it is quite difficult. And it even relays back to the car industry as well. It's difficult for some people to have EV chargers because we simply don't have driveways and stuff like that. So primarily, it's very difficult down to our housing stock to go full heat pump. However, with a hybrid, if you're just looking at 2 components and a smaller heat pump in the garden, it becomes a lot more manageable. Second point is the distressed purchase market. So I think, don't quote me on this, but about 80% of boiler sales are down to a distressed purchase. So that means someone's boiler's knackered, they've got no heating, they've got no hot water. They're not going to hang around and wait 2 months to have a heat pump installed. They're cold, they want to get it sorted as quick as possible. They just get a boiler swap because it's the cheapest, it's the most effective way to get your house back up and running. However, with a hybrid system, it gives us a key to that market. So we can still swap the boiler. I can go around to Mrs. Jones' house tomorrow, I can fit her a new boiler, and then I can arrange with her maybe a week or 2-3 weeks later to get in there and actually add the hybrid system, so add the heat pump to the system and create the hybrid. So it hits that distressed purchase market. Another factor is the cost of full heat pump installations. So it's an astronomical cost, and it's not so much purchasing the technology, it's actually what we need to do to run that system at low flow temperature. So we've got to upgrade pipework with a full heat pump. We've got to make sure all of our rads are sized and they're ready to operate at a low temperature. And that initial cost is huge. And even with the government's grant money, you're still asking the end user to pull out quite a substantial sum of money to get a full heat pump installed. Generally, a hybrid system, because we're not having to adapt so much of the existing heating circuit, makes it a lot more feasible and minimises the cost for the end user. Another main factor is we've got rid of airing cupboards. So through the use of combi boilers over the years, and maybe the last 10, 20 years, we have slowly gone around and removed people's airing cupboards. So 60% of UK homes now have a gas combination boiler in. So that's huge, and people enjoy getting rid of that airing cupboard. They might now have a little air covered radiator in there, and then we're going back with a full heat pump install, and we're saying, oh, I've got this pre-plunged cylinder or this larger cylinder, we need to incorporate this back into your property, and people just aren't keen on having a massive cylinder and stuff put back in their property. The next point is customer mindset. So low temperature heating takes some getting used to. The days of walking in, whacking the thermostat up and the house is warm in 20 minutes are long gone with full heat pump systems. We have to operate at a lower temperature, which means having the heat on for longer, looking at introducing a setback temperature so we maintain the thermal mass of the building. So the beauty of a hybrid system is we've still got that gas boiler as backup. So say for whatever reason, you nip home, you're out of your heating cycle and you just want to get heat quickly, you turn the thermostat up, the boiler can ignite, and we can increase the temperature of the property really fast. The next point is the skill shortage. So we've got over 100,000 gas safe engineers versus less than 4,000 heat pump installers. So that is a massive difference. So with hybrid technology, we can utilise them 100,000 gas engineers and chuck in a little bit of heat pumps as well. So it helps our installer base get used to the idea of fitting heat pumps. And if we want to hit government targets of 600,000 heat pumps a year, then we need these gas engineers to transform into heat pump installers. And that leads me nicely onto the last point, which is hybrids are a transitional product. So firstly, they're transitional for the property. So you might have enough money to get a hybrid installed, so significantly cheaper than having a full heat pump installation. And then through the lifespan of the product, so say a couple of years after you've had the hybrid installed, you might look and go, right, okay, I've got a few quid now, I might upgrade some of my radiators. And what you'll see is that heating system will slowly transform into a low temperature system. So the idea is through the lifespan of the product, we've actually made ourselves heat pump ready. So we've mitigated that massive full heat pump cost, and we've used hybrids to sort of mitigate that cost across the lifespan of the product. Secondly, as I just mentioned before, is for engineers. Engineers get used to fitting a boiler that they're familiar with, and also throwing in a heat pump as well, so they get used to actually installing the products as well. So this is an interesting little map. So this just explains, so we're moving on to sort of heat pumps in the UK now. So you'll see on the left-hand side of the screen, the yellow areas, the little yellow dots on the left-hand map are heat pump installs. So that's where we've got the most heat pumps. And then the blue areas are the lowest. And then on the right of the screen, we've got the highly populated areas, so population density. You literally see that these two kind of mirror each other. And it purely is because it's urban areas. So we've just got less heat pumps in urban areas. I think there's quite a few reasons to this. I think one is that natural gas is abundant. We've all got connection to the gas main. So we've generally had fairly cheap to run heating systems. And the other thing is property space. So airing cupboards, outside garden space. So using hybrid technology, I really think we can change the face of this map and make it, practical to get a hybrid heat pump installed in London, Birmingham, Manchester, etc. And if we want to be hitting our targets of reducing carbon and getting 600,000 heat pump installs a year, then these are the areas that we've got to attack first. So I just think it's an interesting document, and I'll be really interested to see this in 5-10 years time and see how it's panned out. So what have we got in the UK? So we've got the boiler upgrade scheme. So essentially, for those of you that don't know what it is, it's a £5,000 grant, and you can get it if you're removing a gas or an oil boiler or a fossil fuel system and having a heat pump, a ground source heat pump or a biomass boiler fitted. So 95% of the grants have been for air source heat pumps. So to keep it for the purpose of this presentation, I'll just talk about air source heat pumps. So you'll see here that the main fact of this is at the bottom. So we're coming up to the end of year one now. We had £150 million for year one, and there's still £105 million remaining. And I think primarily it's because although £5,000 seems like a lot of money, with the cost of a full heat pump install ranging from sort of £8,000 to £20,000, say if the middle ground is 15 grand for a heat pump system, right, the government's paying 5 grand of it, we're still asking someone to fork out 10 grand towards getting a system fitted. And I just think of the sort of the climate we're in at the minute, I just don't think people have got that much money to be spending on a heating system. So it's favoured some, and some people have managed to make the most of it. I think some rejigging needs to be done to make this scheme actually uptake. I think if the government are intending to give away £150 million, there shouldn't be money left if we're giving away free money. So what's happening in Europe now? So we'll just look at our neighbours across the continent and see what they're getting on like. So this is a really interesting slide as well. So this is heat pumps per 100,000 people. So you'll see at the top there is Norway. They are leading by a long shot. So there's various reasons for that, but you'll see Norway, 1 in 4 people have got a heat pump installed. So that's incredible. There's other sort of factors, probably because they're not connected to a gas network, so it makes it much more feasible to have a heat pump. Also, their UK the housing stock, a lot more insulated, a lot more ready for a heat pump, and they just seem to have adopted the technology really well. We're second to last in the UK, which isn't fantastic. So the UK has 412 heat pumps per 100,000 people. So it's not looking good for heat pump technology in the UK. So this has to change. So now we're looking at how other countries are implementing new laws and legislations for future heating systems. So some really interesting ones on here. We've got Germany in the middle there. So Germany from 2024, a share of 60% renewable energy in heating in new and existing buildings, which means a real ban on standalone fossil fuel boilers. We've got another interesting one in here, which is the Netherlands. So the Netherlands have come out really strong here. So for 2026 in the Netherlands, hybrid heat pumps will be the mandatory minimum standard. So that means if you've got a boiler in the Netherlands, and you just want a boiler swap, you cannot just have a boiler swap. It's a hybrid heat pump minimum. And then I'll just read the UK's one at the bottom, so it's just interesting. A ban on gas and oil boilers in new buildings from 2025, so that's no gas in new build by 25. In Scotland, they're actually knocking it forward a year, so they're doing it from 2024. And then there's something about various trigger points from 2025, so it'd just be interesting how the UK sort of keeps up with Europe in this circle. So there has been a recent consultation from the government, and it basically, where you'll see my arrow is at the bottom there, it's got three little bullet points, and the bottom one is of real interest. So firstly, it's improving in-home boiler performance. So that's going to be looking at trying to operate boilers at a lower flow temperature. We've already seen Part L change, where we're looking at a 55-degree rad circuit now. But interestingly, they're further exploring the role of hybrid heating systems, combining a gas boiler and electric heat pump. Now, I've read through the document quite a bit, and there's some interesting facts on there. And I think what potentially we could see, and what would be really great, is they're going to look at getting 100% efficiency on heating products. So obviously, a gas boiler at the minute, installed really well and efficiently, it's 90% efficient, give or take. So they're going to look at having a system that's over 100% efficient. So that would be essentially a hybrid heat pump system can give you over 100% efficiency, because we're using a super efficient heat pump for a large portion of the heating season, and we're using a gas boiler for when it's really cold. So heat pump technology doesn't have to be complicated. So I think it puts a lot of installers off is that the design element to heat pumps and full heat pump installs. We're looking at completely renewing how we design heating systems. We have to pipe size it. We've got to do heat loss calculations to work out the exact flow temperature we need to run the system at to generate the right amount of heat. But essentially hybrids, because they're still with a gas boiler and still familiar to what we know, it does mitigate a bit of this design element. So I'll just explain to you a slight little example here, which I like to explain to a lot of installers, because we get people phone up and they say, I don't understand, how can the heat pump manage the heat load? It's a tiny little heat pump, surely it won't do anything towards the heating. But let's just work it out. So on average, we'll just take this house for an example, has an 8 kilowatt heat loss. So it says here, a house has an 8 kilowatt heat loss. This means it requires 8 kilowatts of heat energy at the design condition. So what this means essentially is when we do a heat loss, we do it to worst case. So this is me saying this house needs 8 kilowatts of heat to get to 21 degrees set temperature inside when it's -2 outside. So that's just for the southeast. As you raise up the country, the design temperature increases. So at -2, I need 8 kilowatts of thermal energy to get my room to 21 degrees. However, it's not -2 for that long. I know it's really cold at the moment, probably not doing me any favours at the minute, but it's not actually -2 for that long. Maybe 2 weeks of the heating season, it's actually -2. So when that design condition or external temperature raises, you'll see there. So at 6 degrees, we've only got 5 kilowatt heat loss. So that's where our heat pump can crack on and do the heating system. So the optimum sort of temperatures for heat pumps as well are around 6 to 7 degrees. So we can really get them high efficiencies as well out of the unit. So when it's really cold and it's -2, stick with our trusty gas boiler. And then when it's a bit more mild and it's heat pump territory, essentially, we can use the sort of really high efficiencies of the heat pump. So we're really fortunate to be involved in this document from the HHIC. We're quite proud to be on there. We're one of the only manufacturers on there, and we've sort of supplied supporting information for hybrids. I recommend this to anyone if you're interested in hybrids and the sort of the power that they can have in the current future of heating. It's a really good document to read. I'll just zoom in a little bit on the graph that we've supplied here. I think this is really interesting. So although you've got a gas boiler and a heat pump, it's not 50-50. The heat pump can actually manage a lot of the heating demand of the heating season. So you'll see here that we're looking at about, I'd say 60% of the heating season, we are heat pump managing the whole load of the heating. So that's a 60% reduction in gas usage on space heating, which is monumental. It's huge. And when you tag that in with a 20% blend of hydrogen, which we could see this year, it's really interesting how much carbon it can actually reduce. But people aren't going to be left cold, because when it is below freezing, we can even use the boiler and the heat pump. So we could use the heat pump to heat to 45 degrees, so we could use it for a low flow temperature, still at a high efficiency. And then we just bring the boiler in with some gas, just to raise that flow temperature and provide the heat that we need in our buildings. So it's really interesting. So the Alpha E-Tech Hybrid. So I was going to get Joe here just to drop a little video in. So I've got a video of me explaining the product and just giving you a little bit of demo of the product, and then we can open to a Q&A and go through any questions and stuff.
Hi, my name's Dan Wilden. I'm the Renewable Product Manager here at Alpha. I just want to talk to you today about the Alpha E-Tech Hybrid. So it's a new product that we're launching at the moment. It consists of one of our gas combination boilers and a monoblock air source heat pump. Now it works, we look at the heating season, and it works over the heating season in different ways. So we break it down sort of spring and autumn, the winter and the cold winter. So in the spring and autumn season, when it's, temperature is a little bit more mild, sort of 7 to 10 degrees, we're looking at utilising the high efficiency of the heat pump. So with a bit more milder air temperatures, we can get a really high efficiency out of the heat pump. And when we dive into sort of winter sort of times, we look at using maybe both products together. And then when it's really cold and the efficiency on the heat pump and heat pump technology as a whole isn't so great, that's when we rely on our trusty combination boiler. So we kind of break the heating season down, and you'll look, and we've got the best kind of fact that we can give about the product is it give you about a 60% reduction in your gas usage in space heating. So for 60% of the heating season, when it's more mild sort of temperature, we'll be looking at a really carbon reduction saving on using it on a monoblock heat pump. Another clever thing we've done about the package is all the products that you need are in one box. So rather than the installer having to buy one thing here and then get another thing from somewhere else, we've actually got all of the stuff that you need in the box, all one product code at the merchant. So it's just a bit more simple install. So I'll go through some of the main features about the product now. So the boiler itself is ready for a 20% blend of hydrogen. So if that's something we see in the future, where we're sending a 20% blend down the pipelines, the boiler's already available to run on that gas. Another interesting thing about the product is it doesn't require an airing cupboard. So typically 60% of UK houses have a gas combination boiler installed. So that means at some point over the last 20 to 30 years, someone's come in and probably removed your airing cupboard and you've gained a vital bit of space in your property. So because the hot water is served solely by the gas boiler, it still gives us our 14.1 litres a minute of domestic hot water, and we don't need an airing cupboard. The boiler is also capable of running on LPG as well, so it can either run on a mains gas connection, or if you're in a more off-grid property, it can run on bottled gas as well. Another interesting thing, which is quite fundamental as well, is we don't need to do any drastic changes to our heating system. So as long as you've had a gas boiler in there already and your heating's run quite well, we can actually run it on the existing pipework and the existing radiators. Now how it works, so it's very clever in how it works, and this is kind of where our smart tech controller come in. So when the engineer's finished installing the system and he's going through the sort of commissioning stages, he'll input the electricity price per kilowatt that you pay and your gas price per kilowatt that you pay from a recent energy bill. And then what the smart tech will do is every time there's a call for heat or we turn our thermostat up, it will do a quick cost calculation. So it will take what's called the COP of the heat pump, so the coefficient of performance, and it will work out the COP of the boiler, and it will compare them against the prices, and it will always use the cheapest appliance at that current time. Another key feature is it doesn't, if anyone can fit a gas combi boiler already, they can sort of sit on a day's training with us, and the idea is that they'll then feel comfortable to fit this product because it's something they're familiar with, and it's a little bit of renewable technology thrown in as well. Another key part is installing a heat pump is a massive cost. If you're installing a full heat pump and you've got to convert your whole system to low temperature, it's a really big sort of end bill that we've got to pay. So we're looking at this product as more of like a transitional product. So you can have this installed at a much lesser cost. You've got a product that you're familiar with, you've got a really small air source heat pump in your garden, and it will differentiate how well your system acts to low temperature. So you might find that already a majority of houses in the UK that radiators are generally oversized anyway, and you could be much more beneficial running at a lower temperature. So this works on like a flow temperature modulation. So with the outside probe, it will work out what flow temperature it needs to run at to provide heat to the property. And in cases where it's not and it's a really cold day, we've got the boiler there for higher flow temperatures for the backup. So it's a really good sort of product that allows a gradual transition to low temperature heating. So another thing to look at is kind of like, if you have this product installed, over the lifespan of this product, you could maybe the next following year or a couple of years later, you go, oh, do you know what, I might upgrade some of my radiators, and you'll see the efficiency change within the packet. You'll see it utilise the heat pump more, and you'll see your house slowly adjust to a low temperature heating system. And this means that during the lifespan of this product, you're building yourself up ready for a heat pump install. So the next product that you have done, you might be comfortable jumping in and having a full heat pump, and your house is almost ready for that transition. Another thing, that all of our boilers accept a preheated cold main, so that means we can input some solar thermal technology. So if the package alone, you want it to be a bit more using a bit of solar and stuff, the draw of the heat pump, it runs on 10.3 amps max current, so it's a really minimal draw of electricity. So systems with solar PV or solar thermal work perfectly with the package. So I'll go on to a little bit about the hydronic setup of the heat pump now and the system. So essentially, it's really simple for any engineers. You take the flow from the heat pump, that goes into the return of our boiler, and the flow from the boiler comes out and completes the circuit, and the return goes back to the heat pump. So it's really simple to install. A little analogy is it's kind of like piping a radiator up outside. So if you've got an existing gas combi boiler or just an existing gas boiler in general, it's a really simple addition to add this into the property. Our domestic hot water works exactly the same as a normal gas combi would, so there's no issues with anything there. So sort of dimensions of the heat pump. So you'll see from the image here, but it really is, for heat pumps, it's a really small heat pump. So we've got a height of 745, we've got a length of 845, and we've got a depth of just 350. So for people with limited garden space that don't want a huge heat pump installed, it ticks a lot of boxes in its compact size. It also only weighs 45 kilos, so you're perfectly capable of putting it on a wall bracket like you'll see here, or we can mount it on feet. There's just a lot of options of where we can get this product outside your house. So, internals of the unit, it's really simple. There's no pump in here. We're just using the pump that's already inside the combination boiler. But in here, we've got some little key features. We've got a little mesh filter. It's almost like a strainer on the return. This is a serviceable part. And with our valves, we can just valve off the unit, clean out the mesh filter, pop it back in. It just helps with a little protection to the system. We also supply with the kit what's called an antifreeze thermostatic valve. So with heat pump systems in general, you have to put what's called glycol into, similar to like an antifreeze, and that's to protect the outside pipework and protect the outside heat pump. Now, with fitting our valve, you don't need to put glycol in the system then. So for installers that are worried about dosing the system with glycol and how they maintain that glycol within the system, you can fit the valve, you can put normal heat and water through the system. So kind of how it works. So we've been a bit clever. We've limited the flow of the heat pump at 55. So if we're ever asking for a flow temperature of over 55 degrees, we're going to use the boiler because that's where the boiler's more efficient. However, when we're looking at lower temperature heating, maybe on a milder day, sort of 7 degrees outside, we can sort of utilise the heat pump then and run the system at a lower flow temperature. And again, like I said earlier, it works on a COP calculation, so it works out the efficiency of the heat pump, efficiency of the boiler, and it will always choose that cheaper appliance. So a little bit about the SmartTech controller, because this is kind of where the brains of the system are. Essentially, it's a Bluetooth controller. You twist it to change it and click it. It can be wall mounted if we want to pop it on the wall. It comes with a receiver, so the receiver is wired into the boiler. This is it here, and this is the bit that's wired back to the heat pump. So we have a wire running from our receiver back to our heat pump, and the controller itself is wireless. There is a little bit more functionality in a sense that this receiver can be connected to our Wi-Fi network. So if you connect this to the Wi-Fi network, this enables you to make use of the smartphone app. We've also got a desktop app as well. So say if you want to set it so when you're driving home from work, your heating comes on, or you want to, I've left the heating on, you can turn it off while you're nipping out to the shops and things like that. So it's just a little bit more functionality. However, it still works via Bluetooth without any Wi-Fi. So if you don't have Wi-Fi, it's not something you're interested in, it can be used as just a standard controller. It also allows us to input the fuel tariff. So your installer will set it up and it will input your current energy tariffs. But you know, things change, new bill might come through, tariffs might change, suddenly there might be a spike in gas prices, it could be electricity that rockets, or we can use our smartphone app and we can adjust our settings and then our system will react so that the cost changes. So that's it for today. And if you've got any questions, comment below, or you can reach us at alpha-innovation.co.uk. Thank you.
Yeah, perfect. Thanks a lot for your presentation, Dan. Thank you for the video as well, which I'll just get rid of now. We've got quite a few questions come in, so we'll try and run through as many as we can, essentially. But yeah, if you do have any more, there's that chat box there, which people are using, and then the Q&A over to the right-hand side as well. So we'll run through some of the ones that have come through the Q&A. Can you guys you see it as well, Dan?
Mm-hmm. Yeah, I've got
cool.
it.
I'll just run through. Is there any reason that you don't seem to install heat pumps under the ground floor, which would recover any lost heat through the floor?
So, I mean, underfloor heating is your best bet for heat pumps in general, just because we're getting that lower flow temperature. So if you've got underfloor heating, for example, it would run at 30 degrees. So as we covered a little bit earlier in the refrigeration cycle, which means that has to work less hard to generate that amount of heat.
Yeah, we had a couple of questions on the heat loss as well. How do they know, Melissa asks, how would they know which radiators need to be upgraded? Do you still have to go through and carry out those heat loss calcs?
So you don't have to with a hybrid, because obviously you've got the boiler there to back it up. So as long as you had a boiler in the existing house already and that the house was getting to temperature and it was the right temperature, you can have a hybrid fitted. However, if you did do a heat loss, and like with any system, if you just swapped a boiler for a boiler and you lower your flow temperature and you upgrade some of your radiators, you're going to have a more efficient system. So I think it goes back to saying, if you had a hybrid fitted, your goal then over the lifespan of that product would be to improve your property ready for low temperature, and hopefully see that, you know, say 60% of the heating season, we could try and increase that to 80-90% of the heating season, so that you're ready for a full heat pump when we switch.
Yeah, so it's like a pragmatic transition. So, like you said, it won't cost you a lot up front, but we can put this in, then we can improve the radiators, or maybe look at underfloor if there's a renovation product. Then we can look at this. Then we could look at this.
That's it, correct. And a lot of times, I mean, we're a lot of radiators are oversized already as heating engineers. We don't go into a property, remove a rad and put a smaller one back. We tend to put bigger ones back to cover decoration systems like scars and stuff. So unconsciously, we have been oversizing systems. You could be surprised to fit a hybrid, and you could be really surprised at how much the heat pump can do already.
Ash asked, can this heat pump be added to an existing system with a different brand boiler, or does it have to be an Alpha?
It's a packaged thing, Joe. So it's a package unit. The boiler that comes with the actual heat pump is basically it's got a modified PCB to enable it to work on the system. So no, a standard boiler would not work with the system.
Yeah, and again, like you kind of mentioned, it's for that kind of distress, isn't it? It's when the boiler goes down, then we can look at implementing the system. If you wanted to move to a heat pump, like you said, you could do that at any time, but it's a longer kind of project, isn't it?
That's right. As long as you can store the heat pump somewhere, you could actually just fit the boiler, couldn't you, Dan?
Yeah. Perfect. We had a question from Tony asking for a bit more information about how the antifreeze valve works.
Okay, so essentially, the E-Tech Hybrid's got an antifreeze function in it. So the installer makes a choice. If he chooses to fit the freeze valve, he enables the antifreeze function. And what it will do is if it detects the temperature of below 3 degrees in the outside unit, it will start the boiler pump, not heating, just run the pump, and it will run some room temperature water out through the heat pump. That'll just prevent it from freezing. The only time the freeze valve will come into play is if there's, for example, like a power cut. We've not had a heating on for such a long amount of time. It works similar to a TRV, so a wax operated valve. And what that will do is, in that scenario, which is quite rare, I mean, if you've got a power cut and it's -2 outside, that valve will then open and it just dump the contents inside the heat pump to protect it from freezing and cracking the heat exchanger.
Yeah, perfect. We've had a question come in from Stephen, which is one that we quite often get. It's always down to brass tacks. But how much does the system cost? And also, could it work with oil and LPG?
The system cost, our list price is 4220. So Wolseley have run with that, which is great. As far as the actual cost is concerned, we think installed the actual unit will cost around £5,000 to £6,000 installed. So it's really cheap. As Dan said, it's almost 50%, even with a boiler upgrade scheme loan on a heat pump, cheaper than a full heat pump install. Okay. As far as LPG is concerned, we do an LPG version, okay, which is simply just a conversion kit for the boiler. Right? We don't do an oil, okay, not Alpha.
No, fair enough.
Yeah, it's available natural gas and LPG.
Yeah, perfect. One coming from Chris. How does the heat pump handle return temps post boiler of say 50 degrees C? Is this a situation which is boiler only? If so, does the heating circuit water just pass through the heat pump?
Correct. Yeah. So it's always an open circuit. We actually use a different type of heat exchanger inside our heat pump. So it's called a concentric pipe heat exchanger. So say, for example, if the boiler's running a flow temp of even 80 degrees, it's still perfectly fine running through the heat pump. But yeah, to answer his question, it's an open system. Essentially, look at it as a gas combination boiler with a very, very efficient immersion heater piped into the system like a radiator.
Yeah. Is it Delta Tier 5? Sorry, Joe. It's Delta Tier 5, is it, Dan?
Yeah, so essentially, when the boiler's operating, it runs at a Delta Tier 10. So that means it's providing, say, a flow of 50 degrees and a return of 40. And then when it's using the heat pump, it increases the pump speed and it'll be looking for a DT of 5. So it'll be a 5 degree difference in flow return.
Yeah, we've had a couple of questions on the kind of installation. So how much space do you need in front of the air source heat pump for the fan to work effectively or servicing?
Okay, so don't quote me on this, but I think we've got the smallest clearances on the market for heat pumps. So, sorry guys, we only need 350 mil in front of the unit to get rid of that cold exhaust air, which makes it really practical to get this product in smaller places. I mean, We could potentially even see this being installed on balconies and flats. It's really practical in where we can actually get this unit. So again, it feeds back to the presentation of our urban areas where it's really difficult to get a heat pump sited.
We've had another one as well, kind of on a similar vein, but how far away does the boiler flue need to be for the air source heat pump to be installed?
So I don't think we've actually got a designated clearance for this. There shouldn't really be any issues. I mean, I wouldn't have the boiler flue directly above the heat pump dripping onto the heat pump. What we like to say is ideally as close as possible. So we've limited it to 10 meters maximum distance. The reason you want them close together is you just don't want to be losing heat in that pipework. If you've got a really long run, you're just wasting heat. So ideally, boiler in the back garden, and heat pump in the back garden, and then your boiler fitted in the kitchen would be an ideal install.
And if they have any kind of questions or comments, obviously, because this might be a new system, like you mentioned in the presentation, boiler installers know about boilers. They might not know so much about heat pumps. Can they get on to you guys on the technical helpline? Is there like resources that can help them when they have these like manufacturer's instructions and things like
that? Yeah, so we've created a really handy little quick install guide that's available on our website as well. And that's just really taking all of the gump out of the full install manual. We put sort of key things for installers to look at. And likewise, all of our trainings free. So if people want to get involved and come on a hybrid heat pump training, so specifically on the E-Tech hybrid, there's training sessions available to book online.
Yeah, perfect. We've had a question about water treatment as well. We've kind of covered in the magazine at the trade show the chemical-free methods like VDI. What is your kind of advice for this kind of system? Because it's both heat pump and boiler, isn't it?
Yeah, correct. So if you're using the antifreeze valve, then you can just put normal heat and water through the system. So anything that you can put through an existing gas boiler is perfectly, it's perfectly adequate to put through the heat pump. So yeah, if you're working on a chemical-free method, it's absolutely fine through the system. However, if you're not fitting the freeze valve, then you need to be looking at some form of glycol or anti-freezing system to protect the outside pipework.
Yeah, perfect. We got another couple coming. We'll run until kind of we've run out essentially. Does it run with weather comp?
Yeah, so that is the primary thing of how it works. So part of the installer's job will be to set up the weather comp curve. So in the installation manual, we recommend if you're putting it on an existing system and you're not doing a heat loss, let's test the water and let's try it at 60 degrees. So we put a maximum flow temperature of 60 degrees in. So that means if the boiler's ever running, it's running at 60 degrees. So firstly, you're getting your boiler banging, condensing mode, and getting the efficiency you need out there. Secondly, you're giving the heat pump a real chance to incorporate in the system. This might be something that the installer may have to change. If the customer comes up and it's not getting on with this, the rads aren't hot, it's customer mindset, then we could look at maybe increasing that flow temperature to 65 or 70, so they've got more of a responsive system.
Another question coming from Mark said, are the heat pumps ammonia resistant and resistant to sea air?
Yeah, so the go on, yeah.
I was going to say they've got a bluefin coating, okay, which is something the Italians use, similar to Blygold. So as far as the UK market is concerned, any installations near coastlines, etc., it's covered. It should be covered. We've got the same situation in Italy where they sold 50,000 units last year, and the bluefin coating is the same as the Blygold coating. Okay.
Did we? I can't remember in the presentation. Did we talk about warranty on the system?
No, the warranty on the hybrid system is 5 years, and that's across the board. It's a package, and it comes with a 5-year warranty. Anybody that's using alpha boilers right now can get 10 years out of the box on boilers. Okay, so we've already been asked a million times, I think, Dan, haven't we? But as far as a starting point is concerned, the warranty is 5 years. Okay, from the start. It could be something we look at increasing on the back of training, and I believe now with the protection pack, which we're doing via AD in partnership with AD, we can offer an extra year. So we can, in effect, say 6 if you buy the protection pack. Okay.
Yeah, we've had a couple of questions about training as well. Is this something that you offer? You mentioned a day's training. Is there any cost involved? So for people who want to kind of go on a more nuts and bolts course, what are the options for the installers?
So we do a full training day, primarily on the hybrid, and that's available free of charge. So if you look and get on our website, it'll show you the various locations that it's coming. It is a new product, so we are in the case of rolling it out. So it's running at our head office in Kent at the moment. We're then looking at a training centre in Scotland and also a training centre in Barnsley as well. So we have 3 main points in the UK, and then as we progress with the product, we'll open up more training centres across the country.
Yeah. In a couple of months, to be fair, we will have Plymouth as well, Warsaw, I know for sure, Corby, and Leighton Buzzard, and I believe Newcastle and Norwich again, maybe March time. So
Oh yeah,
it's all happening.
that's not that far away either. You just mentioned like most of the country by March, so that's not too much of a concern. We had one coming from Pete just a second ago. Can the boiler and the heat pump work at the same time? And how, like you mentioned, when the conditions are good outside for the heat pump, how does it kind of decide which is the most optimal way of working?
So Pete definitely needs to come on our training. Essentially, if it chooses that it's cheaper to run the heat pump, so it does a cost calculation. So like the COP I can get with the heat pump now is more efficient than the gas boiler. It will start running the heat pump. If it's not climbing to the set temperature quick enough, because there's a larger heat loss, it will then bring the gas boiler in, modulate it down as a backup. So we've got the heat pump running at a really efficient temperature, and then we're just using the gas that we need to get the system up to the flow temperature we need. So again, it's all about trying to utilize the product at their best efficiency. So we're never using a heat pump when it's a copper below sort of 2 or anything like that, where it's expensive to run.
Yeah, perfect. You kind of mentioned it in the presentation as well, but we spoke about the boiler upgrade scheme and we spoke about grants. So William asked almost straight away, can you get grants for a hybrid? The answer is no at the minute, but is this something that you hope or expect, maybe like you mentioned, coming into 2023?
To be fair, so go on, Dan, do you want to go?
No, that's all right. Go for it. Go.
Okay. As far as the actual current scheme is concerned, in England and Wales, there is no funding for the hybrid. There is in Scotland. So Scotland, it is funded. It can be through the Homes Energy Scotland, which is an energy savings trust, linked loan, if you like. I think it's up to £10,000 total. But as far as the BEIS consultation goes, we're hopeful that at some point they're going to see that the boiler upgrade scheme isn't working, okay, and that maybe hybrid could be funded. So it's going to take a little while. I believe the return date was 21st of March. So as far as any update on that, it could be another 6 to 9 months away, maybe even 12, who knows, but the quicker the better, really. And I think we're all fingers crossed on that one, hoping that it will be.
Yeah, there's, like you said, there's still quite a lot of that pot left, isn't there? So it would one to keep your eye on. And
I don't think it rolls over, unfortunately. So it's if it's not spent, it'll probably go somewhere else.
Yeah, very good point. That kind of rounds off all the questions that I think that we found. So if you do have any more, drop them in that, and we can always answer them by text. But Dan and Neil, for people watching this, obviously have lots of questions. It seems like an exciting product. Who want more information or to get their hands on it? What's your kind of advice? Where can they go?
To Dan. No.
Go to Dan.
I think the main thing is obviously get on our website. You can have a look at we've got our product brochure on there. We've got the quick install guide, which I think is really important. If you're an installer looking to fit the product, it's so easy to fit hydronically that you don't really need any training on that part. But we need to get our heads around the weathercom and how to implement it into an existing system. So that's what our training day prioritises really. And it's a really interesting training day, and people all come away with passion for hybrid technology.
Yeah, but if you need any more info, we've got the YouTube videos on the Smart Tech controller as well. So there's 4 of those. We will be issuing, as Dan mentioned, the installer checklist that Dan's put together, which will be really helpful. QR codes linking straight to videos, etc. Plus, also we're about to publish selling points, like an aid, if you like, for a potential buyer and installer when selling to a homeowner. So rather than just sell the product on price and warranty, which is generally the way that boilers have been sold historically, this will be sort of some pointers in as much as giving them a little bit of an insight as to how to sell it to the consumer or the homeowner.
And then obviously how the consumer uses it and understands what's going on essentially.
Yeah, that's it. Yeah.
We just had one more. Richard did remind me. Could you integrate a battery pack into the system, which would have a finite capacity of, say, 20 kilowatt hours?
So the straight answer is no, not essentially. I've had this with solar PV. Can it benefit from solar PV? So all we could do, so that the functionality we've got with the product at the moment is we can enter our electric cost per kilowatt hour. So with some calculations, you could work out with battery storage what your actual cost is per kilowatt hour. Yeah, so by adapting that price, we can then utilize the heat pump more, if that makes sense. So if we work out, okay, well, I use X amount of kilowatt hours I buy from the grid, and then how many kilowatt hours I use for my battery, what's my actual charge per kilowatt hour, and that's what I would then input into the controller. Does that make sense?
No, it does.
Just one last thing, Joe. I believe Chris just asked a question or mentioned, if you like, earlier when Dan was explaining about our friends across the pond in Europe. Norway being obviously the main runners, if you like, in as much as an equation of 1 to 4 people have a heat pump. That number that we showed there was around about just shy of 25,000 heat pumps per 100,000 people.
Wow.
Population in Norway, because I had a chance to quickly look, because I didn't have a clue, is about 5.4 million. So it works out around about 1.35 million heat pumps, though, all the same, which does put us in, well, at 412 heat pumps per 100,000. Yes, we are a more densely populated country, but equally it's a pretty poor show, isn't it? When you think the European average is 3,000 heat pumps per 100,000, and we're only at 412. Just gives you a bit of an idea of how far behind the mark that we are, in the UK.
Yeah, like Dan mentioned, it's good. There has been movement, hasn't there? But yeah, things need to change and go in that direction, don't they?
They've got to go very quickly forward. Definitely.
And quickly, yeah.
Absolutely.
No, perfect. That rounds off our session today. Thank you very much, gents, for your time, your presentation, and answering all the questions that have come in. Thanks, everyone, for your questions and comments. This session is going to be available to watch on demand. So as soon as we finish, it's the same link. So if you do have any friends or colleagues that you think might be interested, send them the link. They register. All the chat stays the same. All the questions stay the same, and they can watch this all back, fast forward, rewind, and all that sort of stuff. This is the same for all the Wolsey Live sessions that we've got this week as well. So you can check out the sessions from yesterday and make sure that you register for the ones come up as well. So thank you, everyone, for your time, and thank you, Alpha team, for your presentation today.
Thank you.